Alright, looks like we're live. Hello everyone and welcome to yet another losing session. How about that? I bet you expect that shit to happen. Let's make a little bit of an announcement and officially start the stream. So let's do a red circle, right? Red circle live on Twitch. And what are we doing today on Twitch? So today we are developing a Java virtual machine in Python. Oh, let me give the link to where we're doing all that, and also ping everyone who's interested in being pinged. And there we go, the stream has been officially started. So today's stream is going to be a logical continuation of the previous stream where we developed the parser for the JVM bytecode files, the so-called class files. You can find the source code in here. I'm gonna copy paste it in the chat, and of course if you're watching on YouTube, you'll be able to find this thing in the description. Right, so I don't really want to spend too much time on this project. I just wanted to, you know, have some fun, develop something relatively simple and interesting. And on the previous stream, we managed to actually write a simple parser that can parse the compiled hello world in Java. Right, so it can parse it, it can show all the like sections and stuff like that, all of the constants and everything. So let's actually take a look at that. I think it's gonna be rather interesting. Right, so I'm gonna go to Python. I don't know why I called it like that, but it's called Python. So here is the script. It's actually relatively small. It's only 153 lines of Python code, and it can already do a lot. Not a lot, but I mean enough. So here is the compiled file, right? So here is the source code. It has like a couple of things in here just to test stuff out, but ultimately it's a hello world in Java. You can compile that hello world. I think I still don't have a compiler in my path file, right? But in that case, I just have a class file already compiled for me. So here it is. So and if you run the script, what it does, it actually parses the JVM file and shows you all of the constants in here. Also, it shows you all of the methods, what kind of classes they belong to, the attributes and stuff like that, right? So it can actually parse all of that. And the next logical step would be to try to interpret the bytecode of that file and sort of actually execute it in a sense that find a simple like write an interpreter for the instructions that are already in that file and interpret only them, right? So I want to try to implement a very limited JVM that can only interpret like hello world or something simple as hello world, because then you sort of have the base to extrapolate it and maybe implement full virtual machine eventually, like for educational purposes. You know what I mean, right? So yeah, that's basically the idea for today. So let's go ahead and do that. So let me take a look. So for some reason it tried to save the compilation file, so I'm gonna actually kill it in here. So first of all, the first thing I want to do, I want to set up the environment for my, so I can have the Java compiler just in case. So I'm gonna do source opt Java environment, and there we go. I should have the Java compile in my path. There you go. It takes some time to actually load up, but it is what it is. So what else do we have in here? So I have to go, what is it called? Python. I keep forgetting the name of the project. Right, so I want to recompile this entire thing, and there you go. Let me see. So if we print the class, right, if we here are all of the methods, right, of that specific class. So what I want to do, I want to find the main method, right? So I'm going to try to interpret the main method. So I already have a function implemented in here. find methods by name. So here I can supply the class, and then I can provide the name main. So because of the function overloading, this thing can return several methods. So we're gonna sort of like assert that we're expecting only one in here, right? So if I try to run this entire thing, here is the main method, right? So it has a bunch of attributes, and in fact it has only one attribute, and that attribute is attribute 23, right? And 23rd one, if I remember correctly, is a code. It's actually a name index. That means we'll have to find that in a constance. So, Stepsister Trap, thank you so much for 3 months of tier 1 subscription. Code Wars QMite Plus at Sodding Stream, this is truly a great day. I don't know what you're talking about. Is this some sort of Code Wars event? I'm not really familiar with what Code Wars does, but I'm glad that you're happy. Anyway, so what I want to do now, I want to find the attribute by name as well, right? So I want to find the code attribute. So Copper Casey, thank you so much for 38 months of tier 1 subscription. That's a long time. Thank you for supporting. And Igorip, thank you so much for Twitch Prime. I hope I pronounced your name correctly. I'm really sorry if I didn't. So okay. So I want to take the code of that main method, right? So what I need to do, I need to take the main and its attributes, right? So here are the attributes, and then among the attributes, I want to find the attribute with the name code. Donut Batman, thank you so much for tier 1 subscription. So, and here we have the code, right? So here is the code. And there you go. So this is the bytecode, right? In fact, the bytecode is located in the info array. There we go. So this is the bytecode. But it's not particularly bytecode, it's a code attribute. The actual bytecode is located within this thing. So you have to actually, we didn't finish parsing code attribute, right? So the code attribute is actually this structure. So as you can see, it's actually like there's way more to the code attribute than just like array of bytes. An actual code is located like in here somewhere, right? So let me write a method that would do that will extract the instructions out of the code, like extract code from code attribute, right? Yeah, or maybe, you know what, I think I'm gonna call it something like parse code attribute. It's going to accept info as the bytes, and it will return a dictionary, but I don't remember how you say dictionary in the typed Python, so I'm gonna just like call it like that. Hello everyone, welcome. So how are you guys doing? Alright, so essentially now I need to extract all of that stuff from the bytes. So to do that, I need to open the bytes as the file. So I think on the previous stream we actually figured out that you have to use something like bytes.io, right? If I do Python 3 and import IO, there's this thing called bytes.io. There you go. It basically allows you to interpret it to treat bytes as file. So it maintains the cursor and stuff like that. It's pretty convenient. And this is exactly what I want to do. So do I have IO? Yeah, I already have IO bytes IO, and just provide the info. And I'm pretty sure I can do something like as f, right? So, and after that, I can, for instance, parse. So what's the first attribute of this thing? It's u2, right? Parse u2 from f. And this is attribute name index. Oh yeah. So I remember that I should actually know. So the first thing should be max stack. Right, so it's max stack, and in fact I can actually do something like this. So code is going to be a dictionary, right? So this is the dictionary and this is the code max stack, and there we go. We're gonna just assign it like that. Right, so the next attribute in here is the max locals. And you know what? I'm gonna actually copy paste this entire thing, so I don't have to switch between the pages all the time. And I'm gonna comment it out, of course. Boom. Boom, boom, boom. I want you in my room. So, so max stack, max locals, it has to be parse u2f. Parse u2f. And then we have to do the code length. Parse u4. And then I'm going to do code equal to f read the code length. Right, so this thing sort of like contains the size of like the amount of bytes of the bytecode. So of course after that we have some sort of exception table and attributes count, like additional attributes or something like that, and I'm not really sure if I care about those. Right, so you may have attributes within attributes. This is actually very interesting. Wait, that's so weird. So the attributes are indicated in the name of attributes of code attributes. And those attributes are... So within the code you can have code attributes. But what if the code attribute of code is another code? So can you have like a nested infinite code attributes? Why? Why attributes are tree? What the hell? This is, this is so weird. Like, yeah, the attributes are tree in Java. That's so weird. That's so bizarre. Java attributes tree. If I understand correctly, you can have the attributes, you can add your own custom attributes in Java if you do things like my attribute or something like that. I think this stuff should also appear within the class file, right? And because of that, the external tools can extract those attributes from the files and whatnot. But apparently they are trees. And of course, I just put Java and tree in a query, and the Google thought that I'm learning data structures in Java. Of course, yes, it thinks like I'm a CS grad who learns like data structures and... Okay, so Google's useless. Anyway, I'm sorry. So it's really interesting. So maybe it would be kind of cool to try to learn that. So we have exception table length, and I'm kind of curious. Like, okay, so let me see. So here's the code. So this is in 4. So parse code attribute. Parse code. It's called parse code in 4. Yeah, parse code in 4. I think that will make a little bit more sense. Okay, if I try to parse this entire thing, so this is the code that we got, this is the amount of locals we have, and the max stack. I'm not really sure what max stack means, so I probably need to read about that. Max stack. Give the maximum depth of the operand stack for this method at any point during the execution of the method. Oh, yeah, so essentially... I do understand. So the JVM is a stack-based machine, right? It is a stack-based machine, and it is known sort of at compile time how deep it's gonna go, like how many elements, and you can sort of pre-allocate so this amount of elements on the stack to do all of your dirty stuff. Okay, that makes sense. I suppose that makes sense. So, but I also want to see what's the exception table. Exception table length. Exception table length. And the length is u2. Parse u2f. Right, untable, exception table. There we go. So let's just try to run that, and we have 0 in the exception table. This is actually perfect, which means I can do the following thing in exception length and something like range. And I can say assert false, parsing exception table is not implemented. And I don't have to implement it right now because it's not even used. What's the point of implementing something that you're not going to use? Okay, so in here we have attributes count. Right, so this is the attributes count. Parse u2f, and we already have a function parse attributes that allows you to parse attributes. Right, so that means we're going a little bit recursive in here. That's actually very interesting. So code attributes. So parse attributes, and this is the attributes count. There we go. So let me see what we're going to have. So, and it does in fact have attributes. Right, it does in fact have attributes, but the attribute name index is 24. All right. So let me see. Can I assign this to code attrib? Right, so this is the code attrib. Code attrib. There we go. And within code attrib, I can go even further with attributes, right? So I want to take a look at the attributes, and then within attributes, I want to take a look at attribute name index, right? It's a name index, right? So here is the what? Excuse me. Am I going crazy? Oh, okay. So this thing returned several of them. Okay, so I have to take the first one, so I'm taking the first attribute, right? So this is the first attribute, and then within that attribute, I'm taking the index, right, which I then can use on the constant pool, right? So it's going to be class constant pool, right? So this is the constant pool, and I want to see what's that. It's a UTF and line number table. It's a line number table, and I wonder what is the line number table. Okay, so the line number table is explained in this paragraph. Line number table is an optional variable length attribute in attributes table of code. It may be used by debuggers to determine which part of the JVM code array corresponds to a given line number in the original source code. This is actually very cool. Right, so, okay, so the code itself is an attribute, and it contains additional attributes for debugging purposes, right? So it has sort of correspondence between like lines and stuff like that. This is very convenient, actually. That's so cool. I really like this. so awesome. So, and I wonder how many line number tables do we have in there, right? We can always just go and print the constant pool, right? So here's the constant pool. It looks like shit, so probably have to pre-print it. Okay, so, and line number table, right? So there's only one in here, right? So there's only one line number table, but it's just a name. It could be actually reused by several attributes, right? So it does not necessarily have to be like a separate thing for each individual line number table, right? So that makes sense. Okay, that's pretty cool. That's pretty interesting. I just wanted to double check what are those attributes, right? So, but I'm not really super interested about them right now. What I'm interested in right now is the bytes, right? The actual code in here, right? So let's actually extract that, and here is the code. It contains literally, it feels like it contains 2 instructions. I don't know why. Maybe because it's sort of separated by /r, and it gives me the feeling that it's like 2 separate instructions, but maybe not. Not sure if it would actually go through, and I don't have the funds to test it, but apparently I can gift a sub to the bot. Why does that surprise you? Why did that surprise you? As far as I know, in Twitch there is no difference between bot and user. Which is kind of interesting. Like, for me, I think I'm too old. But in the past, people were making bots with the same accounts as users. So from the technical point of view, bots and users were never different. They were always like the same thing. And I think with the prevalence of such things as like Telegram or Discord, the services that are trying to strictly separate bots and users, people starting to think that it must be a separate different thing, right? Must be a separate different thing. But in fact, for me, it's always been like, yeah, so this is how it was. Everything you can do to the user, you can do to the bot, because bot is a user's thing, right? So it's kind of surprising that Discord, for instance, like very actively trying to separate users and the bots so you can never confuse them, because poor users may accidentally confuse the users and bots and bad things gonna happen. So yeah. You know what I mean? Alright. So, this is the code, right? So this is the code that we need to interpret. And you know what I want to have? I want to have a magical function. I want to have a magical function that basically does execute code, right? And the code is going to be the bytes. Assert false. Executing code is not implemented. Code is not implemented. Execute code, right? So that's the end game. That's the end game, to be able to do that shit. Take the bytes, interpret them. So that's basically JVM, right? So of course, like the actual JVM has more things to it. Like, you definitely need to verify that the class file is correct, because there's a lot of room for an error in here, right? So because it has a weird system of constants and references to the constants, and the cross-references between the constants and attributes may actually point to the wrong types, so you need additional logic that verifies this entire thing. Right, so, but we're not gonna do that, right? So we're not gonna spend any time on that. I'm gonna just like straight up like assume that the file is correct, but the proper JVM should actually do that. Alright, so let me take this thing, code attribute. I need to go back to the code attribute. Right, I need to go back to the code attribute and find the code. So detailed constraints on the content of the code array are, okay. So, I suppose we can straight up assume that these are instructions, right? These are instructions. So type checking instructions. So this is the verification step. But we're also not going to do that. I suppose verification step is kind of similar to WebAssembly verification step, right? And WebAssembly verification step is basically just goes through the bytes instructions and just sort of like meta executes them, right? So usually when you execute an instruction of the stack machine, you push or pop an element from the stack, the value from the stack. But on the phase of the verification in WebAssembly, you actually push and pop a type, right? And you just check that the types match up. So this is sort of like a meta evaluation. This is my term. I don't know what's the official term of this thing, but I call it meta evaluation. I presume that in JVM it is kind of like that, right? So, and we're also not going to do that. I just want to find the table of instructions that I can just straight up execute. I wonder if this thing is usable for that. I wonder if it is usable. So a load instruction is type safe if, but I have no idea what's the code of this instruction, right? So instruction, okay, JVM instructions. Let's try to Google that up. Virtual machine instruction set. Okay, that's very cool. That is very interesting. Assumption, the meaning of master reserved opcodes, virtual machine errors, format of instruction description. This is actually very cool. Java virtual machine instructions are presented in this chapter by entries of the form shown below in alphabetical order and each beginning of the page. Mnemonic. Okay, so operation, short description of the instruction format, mnemonic operand operand. For mnemonic equal operand, operand stack, description along. Oh, okay, so this is the format of the description of this thing. Alright, so AA load. So this is sort of like codes, some sort of codes. And I wonder, so I suppose the first byte is the opcode. Right, so what is the opcode? The A loader can be used in conjunction with wide instructions, and there is a notion of wide instructions. Extend local variable index by additional bytes format, wide opcode, where opcode format e-inc. Wide, oh, and wide is this thing. Okay, that's very interesting. So, is there any confirmation in the reserved opcodes, in the specification, that opcode is always the first byte, so to speak? I wonder if that's a thing, or this is something that I have to assume. If I search for opcode, right, it consists of an opcode. The construction consists of an opcode specifying the version to be formed, followed by 0 or more operands embodying values to be operated upon. Right, but it never actually specifies what is opcode. Is that a byte, 2 bytes, or something like that? It just like doesn't go further. Right, so maybe we have to go a little bit back. Loading, blinking, and initializing. So yeah, maybe we have to do that, initialization, but I don't want to do that. I think it's dumb. I think I'm not going to do that. Okay, I'm going to just assume that it's a first byte. We can try to confirm that by actually trying to interpret this stuff manually, literally manually. Right, we can take a look at this stuff and, for example, take the first byte and see if there is any instruction that corresponds to B2. Okay, so get static. Okay, right, so the get static form. So index byte, inside index byte 1, index byte 2 are used to construct an index into a runtime constant pool of the current class, where the value of the index is... Okay, this is actually pretty cool. Okay, so let's actually try to interpret these things manually. I think it's a cool idea. I really like that. Okay, so this is OX. Oh, maybe we can keep it like that. So, and the first 2 bytes is this, right? So you take the first byte, you move it there, and then this is the second byte. So this one is 0, that means we can straight up ignore it. And this thing is essentially, right, it's 7. Well, why did I expect anything else? Right, so it reaches for the 7th. It reaches for the 7th element in the constant pool. But I wonder if it actually starts them, the runtime constant pool item at the index must be a symbolic reference to a field, which gives the name descriptor of the field as the value of symbolic reference to the class, blah, 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 blah. Right, so, and here is an interesting thing. Usually the constant pool is referenced starting from 1. Right, it's indexed starting from 1. So let's actually try to see class constant pool, right, and this is 7, right, and we have to do -1. So let's see what's there. Constant field. Okay, so this is like the field. Index. Static field from class. And this is kind of weird, right? This is kind of weird because what field of the class we're getting? Oh! Yeah. I think that's what we're doing. Right, so yeah, get static. Yeah, so out is a static field of a system class. That makes sense. Okay, yeah, the first thing we do, we get a static field of the class system. We can actually go further, right? So name type index. We can take a look at the class index, right? So, and if I'm right, the class index should point at the system class. Right. Lost algorithm. Hello, hello. Welcome, welcome, welcome. Yeah, we're already interpreting the instructions. We managed to parse the class file, right? So if I do p print class, right? So this is parsed class file. So this is a constant pool. This is some methods, and within the methods we have the bytecode, and we're literally trying to understand how to interpret the bytecode, right? So the specification is relatively good. So maybe I'm gonna actually put that into the description in here. So these are two specifications that we're using in here to do that. Okay, so let me see what I was doing. Let me try to run this thing. So class index, right? I need class index, and class index is 8. I should probably separate this entire thing. Right, so the class index is 8, and then class constant pool, right, -1, and we didn't, so it says there's no, okay, constant pool, there we go. So, and it's a class, right, so it is in fact a class, and we're interested in the name index of that class, which is 10, and if we take a look at the name in a constant pool as well, constant pool, like so, -1, it is system. I was right. This is so cool. This is actually super cool. What's funny is that to actually properly interpret that, that means we need to parse the system class. But maybe we don't. Right, this is our JVM. We can do whatever you want, whatever we want. We can, for instance, hardcode, right? We can find the patterns. If you're trying to find object out, so we can have our own out, right? And we're gonna implement it ourselves. We do not necessarily have to load the system things. We can sort of substitute them, right? So yeah. Alrighty. So we interpreted this instruction, right? So we managed to interpret this instruction. Basically, load system out, right? So load system out. So the next instruction. So the next instruction is 0x12, right? So this is 0x12. Push item from runtime constant pool. Let me guess what's gonna be the runtime value from a constant pool, right? So let me see. If we take a look at the original code, I'm pretty sure that the value that we're gonna push from the constant pool is gonna be a string literal hello world. So first thing we push onto the stack is a reference to the out object. The second thing we push onto the stack is the string literal, and then probably the third instruction is going to be call println method. And probably maybe there's another hidden instruction that will return from the function, right, or something like that. Or maybe they return automatically when you reach the end of the code attribute or something like that. How about making some function with a short name to make getting stuff by index shorter? That sounds like a cool idea, but we need to make sure that our code compiles, right? I cannot just say, okay, call this function, because I won't be able to compile that code in the first place, right? Because it will say that println is not found, right? This has to be something that the compiler, the original compiler, can't find. And if it cannot find that, I can't compile it, I cannot get any bytecode. So that means I have to play by the rules, right? To some extent. Of course, I can break the rules, right? But the code that I'm trying to interpret, like, it has to be compiled. Right. Oh, something like shorthand in Python. This is a... Oh, basically, you're bothered by me repeating constant pool all the time. This is a temporary code. This is a temporary code. In fact, I'm gonna just remove it right away. I don't need it anymore. Right. I see what you mean. This is a temporary code. I'm just iterating. This is... the code not necessarily has to be final all the time. So, treat this part of the script as bash. It is very dirty, and it's needed to just get some information, check some hypothesis, and just remove it, right? So it doesn't have to be pretty, it doesn't have to be like the final code. Of course, I'm gonna try to have some shortcuts, but here it's a throwaway. I don't really care about it right now. Sorry. Okay. So this thing is LDC, and the index. Where is this thing? Oh, and here is this. Here's the index, and that's why it looks like that. And I don't remember what is /r. What does it equal? So I can always do something like printf_r, and can I do xxd? So it's 0d, right? And then if I do d, it's 13, right? And then if I print class constant pool 13 minus 1, what does it equal to? This is not what I wanted. I wanted to do that. So string index, it is in fact, as you can see, as I said, it's a string literal, right? So then we can take the string index, right? Then something like this. Let me see. It's a hello world, right? So as you can see, we're pushing this this thing to the stack as well. Excuse me. Okay. Let me see. So we parse that. So the next instruction that we need to take a look at is B6. Let me put it. Okay. LDC hello world. So this is what we're doing here. So B6 invoke virtual. Okay, and it accepts 2 bytes in here. Ooh, okay, this one is interesting. So that means there's another thing. So virtual, and the indexes here is 15. So invoke, yeah. So we can take a look at what's that. What's that? Ooh. It's a method reference, right? It's a method reference. We can take a look at the... So it also contains the class. I suppose the class is going to be the output class thingy. So maybe output array or something like that. So we can just do class index, right, -1. So this is a class, right? And if we do name... What was that? It was name and type. Name and probably name and type. And name and type is literally name and type. So yeah, okay. So I suppose it's just like calling the method of the output stream or something like that. So it's really, it makes sense. So the last thing I'm interested in is so this is invoke virtual. Invoke virtual b1. B1. What's that? Return. This is precisely what I said. It has this last invisible instruction return. And I wonder what's going to happen if you don't generate it. What's going to happen if you don't generate it? So this is actually rather interesting. But yeah, so we managed to sort of disassemble by hand all of these instructions. And what that means? That means we should be able to write some script that will interpret all of them. It's actually very cool. Okay. So let me put that somewhere. Right, so I'm gonna actually put it somewhere here. And that's literally what we're gonna do. So what I'm thinking, I need to sort of take those bytes, byte by byte, if you know what I mean, we can reuse that bytes IO yet again. Right, this is actually very cool. So I can do with IO bytes IO code as f, which means I can do stuff like opcode equal f read u1. Actually, like read u1 f. And then I can do the following thing. If it is equal 0xb2, right, so opcode, if it's equal to that, I can read the index parse u2f. And then within that thing, I can do class constant pool index -1, of course. So this is actually pretty cool. So that also means that we have to accept class as the parameter here as well, right? But it also would be nice to have some better mnemonics for these things, right? So let me actually find 0xb2, right? So this is going to be get static. So let's do get static opcode 0xb2. So this is get static opcode and get static opcode. Right, and in here we can do the following thing: assert false f unknown opcode, and we can like literally put it in here. There you go. So, and this is actually super cool. You know why? Because we can just start generating a bunch of JVM files, different JVM files, and try to run them, and they were gonna fail at unknown opcode, and we will know what opcodes we need to implement to make a certain program work. And you can iterate that and eventually maybe implement the full JVM. I have no plans to implement the full JVM. I just like, this is probably gonna be the last stream where I work on this project, but this is a general approach to implementing any kind of virtual machine, right? So in fact, quite often when people implement like a Game Boy emulator, right, they take their favorite game, right, and they write a minimal emulator, right, and they try to run the game on that emulator and it fails on unknown opcode. They implement that opcode and run it again, then it fails on a different opcode, they implement that opcode, and eventually they're implementing the whole emulator. So this approach works with any virtual machine, right? So, and you can do that for JVM as well. So for JVM it's going to be a little bit longer, JVM is a little bit more verbose, older and stuff like that. It has a lot of conventions, stuff like that, but it's the same approach anyway. This gives me the vibe of Game Boy. This is literally what I was talking about. Yeah, exactly. So that's funny. Yeah. So this approach like works for any emulator or virtual machine. In fact, emulator is just, it's a virtual machine, right? The only difference between JVM and a Game Boy is that a Game Boy emulator is that the Game Boy emulator emulates a real existing machine. And a JVM is a fictional machine that doesn't have any hardware like a real-world implementation. Maybe it does. I heard somebody was trying to do that, but it didn't really go well. Right, so the only difference between them is that one is more or less real, at least was, and another one is fictional. The same approach I used to implement in x86 simulator. Yeah, so it's a very cool approach. And it's actually a very routine approach, right? So you can even sort of kind of zone out and just like keep running it and then implement the next opcode and the next opcode and the next opcode and so on and so forth. Virtual machine, yeah, exactly. Okay. So load system out. So this is going to be get static opcode, and then LDC opcode is going to be 12, and invoke virtual opcode B6, and the last one is going to be return opcode is B1. Right. And I suppose, what do I want to do? I want to do the following thing. Is if opcode equal to that, we have to be slightly more careful in here. This is not what I wanted. And then in here I'm gonna do assert false. That was dumb, but yeah. C of code is not implemented, right? This one is not implemented, this one is not implemented, there you go. So it would be also kind of cool to tell exactly where it is not implemented, but maybe we can extract the cursor from the bytes IO or something like that. I can shake off the feeling of my failed attempts of interpreting JVM. I always struggle at bringing code from other classes such as system. This is precisely what I was talking about. Why? Why are you making your life more difficult than it should be? You can just hard code that, right? If you see instruction trying to reach to other classes, just fake them. Like literally fake them on the level of JVM until you figure out how to properly do that. So why? Why making your life more harder than it is? So when I can do this thing, what I'm gonna do, I'm gonna maybe create a special frame on a stack that says, oh, this is a fake class. It doesn't, this is a fake class. And if you try to call the methods of other fake class, it will just call a fake method, right? So that's how we're gonna do that. Okay. All right. So there we go. So let me see. So for how long I'm already streaming? So maybe it would make sense to make a small break. What do you guys think? So let's actually make a small break, and after the small break, we're gonna try to actually emulate this entire thing. There we go. So I'm gonna do the subscribers booth. There you go. You guys are free. I need to do type 2, so 5 minutes. Yo, what's up? What's poppin'? What's hoppin'? Alright, so let's make some break and you guys have fun. Yo, what's up, epic gamers? I think it's about like 4 minutes. Right. Does anyone have any questions while I'm waiting for my tea to steep? Do you still keep a keyboard and Alex? Yes. I have a very small table. I have a question. Do you use Ctrl N, Ctrl P, Ctrl F, Ctrl B? Yes. Does anyone have any question? The function return list in main is set to the first. Okay, so this is probably not the question. Function, what's up? What's up? What's up? How's it going? How's it going, my friend? Which distro is it? This is no, fetch Arch. What's the difference between an emulator, like Android emulator, and simulator? One emulates and another simulates. The question is, why does the difference matter between them? Are you into CTF? Not yet. To be fair. Probably never be, because I'm not into competition. I get really stressed out. Okay, bye-bye. Most algorithm, bye-bye. Hello, hello. What's up, Datunka? Just curious why the iOS one is typically called simulator instead. I don't know, but I have a hypothesis is that might have something to do with patents and branding and some other shit, right? So you have two huge companies like Google and Apple with shit ton of lawyers, right? And they're trying not to call the same things that they create the same names, right? Maybe one is calling a thing an emulator just to not get into trouble with Apple or something. I don't know. This is my hypothesis, but I have a feeling that it has nothing to do with like actual technical shit. Right? I actually doubt that. But I don't know for sure. This is my hypothesis. Yet again, I might be wrong. Keep that in mind. All right. Get some tea. I've got my tea, everyone. I wonder how you support things like threads in a custom JVM. You just create a thread. Look. Right, if you need a support for plus operation, how do you implement a plus operation in your JVM? You would use plus operator that is available in a language that you're using to implement the JVM. How do you add support for minus operation for your custom JVM? Well, you use the minus operator that is available in the language you're using to implement the JVM. How do you implement threads for your custom JVM? Well, you use available mechanism for threads in your language. It's like, I don't see any difference between these three things. Like, seriously, like, yeah, that's how you do that, right? I'm sorry, maybe I'm dumb. Maybe I don't understand the question, but that's how you do that. You need to implement something, you just implement it. Right, however you want, right? Or maybe also depends on the spec or whatever. All of that is just like minor details, right? None of them actually matter. What matters is the, whole picture, right? The details, you can manipulate them. They don't really matter that much. They don't really matter that much. Alright, so I got my tea, and let's try to implement all this, right? So I wonder how we're gonna do all this. So what I'm gonna do, right, so we have code trib, right? I'm gonna run that, and I'm going to try to execute that. Right, I'm gonna try to execute that, and it should fail. Executing one required, oh yeah, so you have to also provide class, right? You also have to provide the class. And it's not a read you one, it's actually parse you one. I got everything wrong. Get static opcode is not implemented, right? So can I actually jump to the place? Yeah, I can straight up jump to the place where that should happen. Okay, cool. And now another thing I can do index. Right, let's actually go like this. Parse u2. Guligon90, thank you so much for the sub. I'm really sorry if I missed anyone. Donut Batman, thank you so much. Nico Red H, thank you for all of the subs. I really appreciate that. Okay, I'm gonna provide this thing, and I want to actually print. Right, get static. I'm gonna put F in here, and this is gonna be the index. Right. So get static 7. So this is the instruction that we got. You know what? What if I implement some sort of a disassembler for now? I think that's a cool idea. Right, let's implement a simple disassembler. Right, so I'm going to go in here, and it encountered unknown opcode, which is rather weird. Oh yeah, I know what the hell is going on. Yeah, so I supposed to... For a second, I thought that I organized a proper loop, right? So what I wanted to do here is just I wanted to organize it like that, like while true. So the specific condition doesn't really matter right now. Right, while true. Then I want to chain those things together, like so, elif, and that should work now. But the question is, like, up until what I have to do that. So let me actually check what kind of things I have in the IO bytes IO. Hello, Fuzuri, thank you for coming. Alright, so let's put some stuff in here. So I have main, right, and let me see what kind of methods do we have in here. I can't see much stuff, but I wonder. Is there any way to check that we reached end of file? Python check end of file. So there should be some sort of a method or something like that. Let me see. Or maybe it throws an exception. Who knows? Maybe it throws an exception. So fred reads up. Oh sure. No, this is not particularly what I want. So it will rise an exception. Really? That's what it does? It rises an exception? Okay, I can try to read 4 bytes. Okay, this is 4 bytes. If I try to read 69, it doesn't really rise anything. Oh, I suppose it will just return nothing then. Okay, for instance, if I try to do something like this, right? Which means that in here, if I try to do from bytes, right? So if I do int from bytes from an empty thing, and I'm gonna say big, it just ends up being 0. So it is not particularly easy to actually get that. So Stack Overflow is not really useful in that regard. Oof. It will just return an empty string. This is not particularly convenient. This is so bad. If I had a way to simply control... Okay, so since it's a bytes, maybe it would make sense to actually maintain our own cursor then. Right. So I feel like we have to maintain our own cursor. Which is kind of nah, but yeah, it is what it is. But I mean, in here, we should be able to have that cursor somewhere. Right, so, well, there is a tell. Wait a second. This is perfect. Right. And if I keep reading, the tell is not increasing. So if I do if like that, initially tell is 0, then I can read 1 bytes, and tell is 1, so this gives me the actual cursor. So let me actually read help for this. Okay, this is perfect, thank you so much. So what that means, while ftell is less than the length of the code. Easy peasy lemon squeezy. That's how we're gonna do that. And the reason why I still want to use IO bytes is because I already have a function that uses the file API to parse things. Right, I'm using the same function to actually read from file and also read from memory. Right, I don't want to. Anyway, so here I'm gonna get the index, and this is parse u1 f, and here I'm gonna just print f something like index, so it's LDC index. There we go. So get static LDC 13. Right. So invoke virtual, and invoke virtual also accepts some stuff. So it's going to be index parse u2f. Invoke virtual. And the last one has to be just return. There we go. And yeah, we have this thing, so let's actually remove that. There we go. So we got a disassembler. Which is rather interesting. So what if we make it a little bit more complicated, right? So what if I say that I have also system out printf. It's probably going to be too complicated, but can I do something like println 34 plus 35? What's going to happen if I try to do something like that? Java C main Java. So I try to run this entire thing, and okay, it managed to successfully parse the code, but now it fails on opcode 16. You know, I actually want to print that opcode in hex, so it makes it easier for me to then search it. Okay, so it already has 0x prefix. So let me find that thing. Where is this stuff? By push byte. Okay, and then the bytes that you're trying to push. Okay, that's cool. By push opcode 10. Right. Leave opcode by push. Then the byte that you're trying to do. So it's going to parse u1f, print f by push. Byte. Okay. Oh, look at that. 69. The compiler evaluated this at compile time. Right. This is actually kind of cool. Look at it. It evaluated at compile time. Yeah, Java compile time. So if you ever wonder, does the Java compiler do anything at compile time? It does. For instance, it folds the constant. right? It folded the constant and now it's 69. HTTPS Miguel, thank you so much for Twitch Prime. Jerry, by the way, thank you, thank you, thank you. Yeah, that's pretty cool. So, and what's funny is that we had to introduce only a single thing in here, so that's pretty cool. Okay. So let me do something like class constant pool, right, to -1. And I wonder if we can do that for all of them, like so. So virtual index class -1, and there we go. Yeah, now we can literally see all of those things. So get static, get that. Oh, and what's interesting is that, look. I'm gonna remove the index. Yeah. You may notice that we're calling to the same method, println, but invoke virtual actually points at different methods. So it dispatched it at compile time by type. So overloaded methods, and it actually literally calls to different versions of the same methods. So that's pretty cool, I think. So we can actually confirm that. So this is so cool. You can like literally explore how all of that works and just have fun with all of that. Right, constant pool. Right, so -1. So these are the methods. We can see that the class is literally the same. It's the same class, but the methods are different. So this is going to be the name and type. Right, so let's actually grab the name and type. This is not what I wanted, in fact. Name and type. And we can use that as a class for this entire thing. Right, so this is a name and type. Right, so after that we have to take the name index. Right, so this is the name index. I know that it's a little bit frustrating to have these long chains of things, but I'm gonna remove them anyway. Yeah, there we go. So these are printlns. These are literally printlns. Okay, so I think we're actually ready to try to implement the interpreter of this entire bytecode. So one interesting thing is that I suppose when you load a class, you also have to initialize that class, right? So we have to call the initializer. But we're not going to do that, right? So this is extremely limited JVM, extremely limited. It won't surprise me if Oracle JVM spend most of its time with constant pool querying. I would not be surprised if something like advanced, like Oracle Hotspot, actually internally uses a better representation that allows you to do that faster, right? So maybe internally it may take the constant pool and sort of like transpose it, put it in different arrays, so it can quickly like find, identify and stuff like that. It may like use a completely different data structure than the actual file offers, but maybe not, who knows. So from what I heard from people who work on JVM, JVM Hotspot uses a lot of weird voodoo magic to make your code run faster. So, and probably it stores the class files completely differently. All right. So we need to have some sort of a stack, right? We need to have some sort of a stack. Let's just go ahead and allocate the stack. And people are going to be mad at me for not using a deck, but I'm going to use the list instead. I'm really sorry about it. I'm going to use the list instead. I know that deck is way faster, but this is Python. Python is not meant to be fast. Anyway, I'm sorry. Okay. So get static. I want to take a look at get static one more time. So this is specifically get static field, right? Get static field. Who even uses deck? That's a good question, actually. Constant pool. Actually, this is not what I'm supposed to do. Class constant pool. Right. So constant pool. And this is a class. Static field from a class. And then name and index. I want to assert the name of this thing. I want to assert the name of this thing. Get static 10. Constant pool. Okay, one more time. I think I'm falling asleep. I'm already tired. Right. I'm already tired. Okay, just a second. Constant pool. Not constant pool. Jesus Christ. Class. Constant pool. Index -1. Alright, so this is that. Field reference. So what I'm thinking, okay, so I'm gonna actually do it like this. Field ref. Right, so this is a field ref. Maybe here I'm gonna do assert false. Right. Print field ref. So then, what I need two things. I need class index and name and type index. Right. Class index, and I'm not even sure if I really need class index, name and type index. Right. I'm really not sure if they're that important. I'm going to show you why. So this is them, right, 8 and 9. And then we can just do something like this. Something like this. Right. I was hoping that maybe name and type would refer back to the class, but doesn't refer back to the class. But the name index should refer... Okay, so maybe that's fine. Maybe that's fine. Name and type. What I'm thinking is that we can do something like this. Name of class. Right, so we accept class, and then class field. Right. So this is a... It's not really like class. Class constant, rather. Why do people keep talking about money? Do you guys have anything else to talk about in your life? Let's talk about programming already. Okay, so let me see. So this is a class index. Maybe we should accept like a class index then. Yeah, I think it would make a little bit more sense. Class index. Class index. And then I can take the name index. This thing. Emacs is kind of weird in terms of that. -1. And we'll just return. Right. Name of class. Field ref. Class index. Yeah. And it didn't work. Because it also accepts class. Emacs, what the fuck are you doing? Okay. Alright. Okay, so, and in fact, then, later, I want to get the bytes. Right, I want to extract the bytes. And that's totally fine. Okay. So, name of class, and then... name and the type. Name of method. Right, name of method. That's what I want as well in here. Class, name and type index. And speaking of name and type, name and type. What is it? Is it specifically for method? Field or method. This is actually field or method. So that's not particularly great, but it is what it is. Name of... let's call it member. Right, so because name and type can describe both fields and methods. What's the collective name of fields and methods? I suppose members, right? But it's more of a C++ terminology, but I mean, who cares? We're implementing JVM and Python. Who cares about terminology? Alright, so let's continue. Constant pool, and in here I'm going to do class, name, and type index. And class constant pool. Name of member. And we also have to accept the class. Index. Constant pool. -1. Bytes. That's precisely what I want. Cool. So this is name of class, and this is name of member. Ooh, okay, that's cool. And essentially, we want to have some sort of like dictionary that we want to push into the stack, right? So we want to do stack, append, and in here we want to have some sort of a type, right? So this is the type, and the type is maybe fake string, right? I wonder what's the type of a system out, right? A Java API. What's the type of the system out? I think it's an output string. System out. Okay, can you even find system in here? Java API system. So let's actually go there. And it's a print string. Right. So we can do something like fake print string. Right. and that is basically it, right? And we're only gonna do that if name of the class is equal to this thing, right? So it has to be equal to this thing. So if it's not equal, we have to throw some sort of error. I don't really know which one, but yeah, we have to throw that. And the name member has to be equal to out, right? So this is basically what we're going to be doing. So that's why I was like spending so much time to get it right, so because I want to assert, okay, so for the class system, for that specific opcode in the class system and the member out, we're gonna push onto the stack a fake print stream. And then if we encounter a fake print stream in virtual call, basically the trick in here that I'm doing, right? So what I'm going to do, so let's actually like say an expected class, So I want to refer to that name, so that means I need to save it somewhere, so it has to be name, right? So this is the name, but I want to call it the name of class. Right, so, but the name of class is already taken, so maybe I have to say get name of class. Where is that? Get name of member, get name of class to indicate some sort of action. Right, so the get name of class. Unexpected class name of class. In get static instruction. Does the system out contain the same index every time? Why does it matter? If you're faking things, why does it matter? If you're faking them by name, doesn't matter. Okay, so name of class is not that. And name of member. Unexpected field name of expected member of member in class name of the state of the stack every time. So we can do print stack. We can even do something like we print the instruction that we're doing, right? So to get static and the index, right? So this is the index. Get instruction, the index, and maybe here we're gonna do something like, okay, that's the state of the stack after executing that instruction. And local name of member is no dereference, blah blah blah. What are you talking about? Right, so what do you want from me? Because it has to be get. Sure. Okay, cool. So this is the fake stream, and it pushed the fake stream 2 times. Okay. So, what do we have in here? LDC. And LDC is pushing the constant, right? LDC, push item from runtime constant pool. And maybe, so I'm just thinking how we go class constant pool -1. Right. So this is a constant string. You know what I'm thinking? We can append the following thing. Stack append type constant, and then the constant itself, maybe just called const, is going to be that. Right? We're literally going to take the constant and we're going to put it there. Why not? And this is going to be the index. Alright. So, okay, that's cool. So we need to look at the thing after that. Right, so we have a fake string, we have a fake constant, and then we invoke virtual15. And invoke virtual15 is rather interesting. So, you know, to simplify things, I want to actually get rid of the second thing in here. Maybe not, maybe that's gonna be fine. That's totally fine. So virtual invoke, this is the index, and let's do class constant pool -1 class invoke virtual, so it's a method to ref it's a constant so it accepts the class name, right? So it accepts the class name. Let me take this thing, method to rev. So this is the method to rev, and within the method to rev we have class index, right? And we also have get name of class, and we have to provide the class index. So we can do get name of class like so. Here it is. Here it is. It's a print stream. Okay. Name of class. It's a tiny bit noisy, you know? So I think it makes sense to actually assert those things, right? Assert false and something like this. Name of class. Alright, so the name of class. Yeah. So this is the name of class, but that's not enough. We also need to get the method. Method ref. Name and type index. Name and type. Get name of member. Right. And I can even duplicate that. So member. Okay. So here are two things: print stream and println. We can also fake them. Right, we can also fake them. So invoke virtual. How are we going to do all of that? First of all, we have two things onto the stack, right? So we have some sort of a parameter, and we have this thing. How do we know? Okay, I'm gonna do a similar thing, right? If name of class is not equal to this stuff, it's not equal to this stuff, I'm gonna copy paste this thing to here. Class name class in invoke virtual instruction. Okay, if name of member not equal to print, we're gonna do the same thing, but I didn't specify in which instruction. In get static. instruction. Get static instruction. Invoke virtual instruction. Okay, cool. So, and once we've got those, right, well, once we know, it's actually rather interesting. We can do the following thing. If name equals that and member equal that, we execute something. Right, we can assert Java println is not implemented yet, but then we can say unexpected or maybe unknown method name of class / name of member in invoke. Yeah, so basically you have like dispatching by 2 parameters, and then if you need more classes and methods, you just append them in here, and you can use the same approach in here as well. So as you can see, I intentionally wrote this code messy, so eventually I can come up with this idea. Right, so and, so it's not equal, right, so it has to be equal. Right. Don't be scared to write messy code, because it allows you to explore the patterns and then discover some patterns. So it's a good thing. And the implementation of this thing is just like fake print stream, right? So fake print stream. And print stream, by the way, has the type of this thing, and we'll be able to verify that down later. Ellipse0934, thank you so much for tier 1 subscription. Thank you. Okay, so we're gonna do that. Unknown, let's put it this way. Unknown member in get static. Right, in get static. So if this one is equal to that, yeah, and it makes it super easy then later to add more and more things, right? So like sort of like stab more and more things in here. Right? Okay. So let me try to run this thing, and it says print stream println is not implemented yet. Yeah, there we go. Okay. So now what we need to do? We're gonna assume that println accepts two arguments. We're gonna hardcode that as well, right? So if stack len less than 2, we're gonna assert the following thing: false name class name of member expects 2 arguments, but provided this amount, right? Arity, but not really arity. Let's actually put n here. 2 arity. So this is false. Expects 2 arguments, but provided that. Okay, cool. So stack minus how to do that. So I remember that maybe with this kind of thing you can do -1, not really -1. Don't remember. Right, so you get that one, then you get that one. I think it would be easier to just do something like len stack. I can never remember how these things works, I'm sorry. So -1 and -2 in here, right? So this is the object, right? Well, I can't use the word object, it's already taken, so this is the object, and we need to check what its type, right? What's its type? Well, I'm just thinking what would be the best thing to do in here. We can say that we have some sort of a function like type of, and I think type of is already taken. How do I already have a subscription mode? How people literally pay me to backseat me. This is so annoying, and I don't even get any money for that. Type of is not okay. So type of, we can create a function type of. So what is it going to be? So probably it has to be some sort of a frame, right? Right, and frame type is equal to fake print string. And so what's going to be the so this is the type, and there we go. Type of is not implemented. Maybe I should actually start like enabling the emote mode or something. It's just like it's unbearable. Okay, so this is the type. So type of obj, if this thing is not equal to this stuff, we should say expected type this, but got, and of course I need to, and it's already taken. So annoying. Okay, so this is the type, so this is object, and this is the type of the object. This is the type, this is the type. Okay, cool. Expected type, but got this. Alright, so we confirm that everything is okay in here. And this, then we need to have an argument, right? Stack len stack -1. So this is the argument, and depending on the type of the argument, right? So we're also gonna do different things, right? So for the type of where I just lost this thing. Okay, type of This is the most backseating message I've ever seen. Okay. Okay, I think I need to simplify this thing. I'm gonna remove this stuff and just recompile. So we're only gonna do the strings. Alright, so we're only gonna do the strings. Alright, so println is not implemented. And the argument, if the argument type, so what is the argument type actually? Let me see. Okay, so this is not what I want. I want to run this thing. It's constant, right? I can do something like this. If not equal constant, assert false support for arg type. Is not implemented, right? Something like this. And since it's a constant, then I can take the const. Within that const, what do we have? What? Where is it? I see it. Maybe, yeah, okay. So this is the constant, and then in here, okay, so that means here is a const. Right, so then if const tag not equal constant string, const tag is not implemented. Yeah. Const tag string index. Const tag string index. Wait. No, it doesn't have to be tag. It's that 14 class constant pool -1. Okay. Bytes. Decode. UTF-8. Hello world. Return. And we can actually... Let's actually remove all that shit. And... that. Now, hi, chat. Chat, look, chat, wake up. Hi, chat. We implemented a simple JVM that can interpret only hello world. Right? Yes, full bar. And I can actually do something like JSC Java main.py, and there we go. So we can do that. So, and it only works if you provide the string. It doesn't work with the constants. Right, so it should say something. Yeah, so you're trying to push some sort of a number. So, and yeah, let's actually go there, somewhere here. Yeah, so this thing is not implemented. We can try to add support for that. So this is going to be literally integer, right? So we're gonna say type integer, and value. Let's put it this way, and the value is literally going to be byte. Okay, so I'm going to just try to recompile that one more time. So it's actually append. So I can start extending this thing like this, right? So I just like implement something, rerun this entire stuff, and now we don't have a support. Well, it has to be f, right? So let me put it this way. So for integer is not implemented. Okay, that's totally fine. So if it's a string, right? If it's a string, we just do that. Then otherwise, if let's put it this way: if it's a constant and string, we just do that. Otherwise, arg type integer, we have to print that integer, which is like literally the value that we put in here. So in here we can say support for type is not implemented. Then we can put it like this. If the constant is that, otherwise support for const tag is not implemented. So this is the constant, and if the constant is string, we print that string. If it's not, we say that it's not implemented. Otherwise, if it's integer, we just print the value of the integer. Otherwise, we say that this thing is not implemented. Okay, can we do that? Keyword const. So what exactly it doesn't like in here? Key error const. So it said, oh well, it has to be equal, not equal. There we go. 69. All right. So now we just added support for both string hello world and integers. So now our virtual machine supports both. Virtual machine support both, and we can even do something like this. Since it's evaluated at compile time, we don't have to worry about implementing plus operation. It will still work. So, and if I add more things, right, for example, I don't know, 420, but it's a float, I can just recompile it one more time and just follow the problems, right? So it says the tag number 4, right? Oh, we even have a problem on the level of parsing. We don't even know how to parse the fourth one, which is the float, right? So as you can see, this system is actually super easy now to extend, right? You just add more things to the original code, you just try to run it, you see where it fails, and you extend it in that specific place. So this is actually pretty cool, right? So, and it's a little bit like tedious, right? But you can sort of work on that in a weekend, right? So it's a weekend project, like make a certain Java program work, right? You have a small Java program and you want to try to make it work. You just like use this approach. And it's quite important to use asserts a lot, right? It's quite important to assert the places that you didn't implement yet, right? So then when you actually go, when your execution goes into that place, you know that this is the place where you have to implement it. And only then this approach kind of works. Right, so let me actually compile, commit everything that we have. All right, so maybe I need to extend. You know what? Maybe I'm going to do that later. So I was thinking maybe I should actually make it look like an actual JVM and accept the name of the class or whatnot. I'm not going to do that. All right. Implement simple JVM that can run only hello world, right? And I'm going to push that right into the repo, and yeah, so the source code for this thing is available in here. I'm going to post it in the chat, and for everyone who's watching on YouTube, it's going to be in the description. So does anyone have any question before I go? So that's basically the objective for today's stream, and yeah, that's actually pretty cool. And you can basically continue doing that, and eventually you may implement your own JVM. So eventually it's going to be pretty slow JVM. Imagine JVM in Python, right? So the Python itself is rather slow, and now you also have a JVM. And this thing, of course, may look messy, but as you extend this thing, you will also notice some patterns that you can factor out and simplify and stuff like that. Leaves. Excuse me. So, does anyone have any questions? Anyone have any questions? I attempted to implement to write my own JVM at some point, and now I remember why I stopped. Yeah, there's a lot of moving parts to JVM, and one way to actually simplify your life is basically hard code a lot, right? It actually generally works for programming for anything, right? So the task may be daunting, but try to implement only the bare minimum, and then once you implement it, it's going to be more obvious how to maybe make it more general. How much faster is it compared to hotspot? I'm not sure if I'm using hotspot, by the way. Just a second. I am using hotspot. So I'm pretty sure it's gonna be faster if you just use time. If you just use time, I'm pretty sure it's gonna be faster. So maybe not actually. Yeah, it is faster. Right, it's 58. Well, they're kind of close. It's a bit slower, yeah. Mine a little bit faster. Who knows why? Who knows why it is faster, even though, despite it being written in Python. Well, the thing is, this virtual machine doesn't do shit. It doesn't even verify anything, right? The proper virtual machine actually probably loads the file, verifies all of the things, maybe even initializes some other stuff, loads other classes and stuff like that. It just like does a lot of shit. This one doesn't do anything, and that's why it works only for that specific hello world. Actually kind of funny. I wonder, is that like a technique that you can use? Like if you need to run only one program, can you develop a custom JVM for that specific program that runs that specific program fast? Or in that case, you can just like basically try to compile it to native code. I think Java validates everything it needs. Oh, it doesn't try to validate something it doesn't use or something like that. I don't know. What chair is that in the background? It's something from IKEA, but I don't know the name of the model. How am I doing? I'm doing fine, I suppose. Just, you know, writing some code, hiding from a government that is trying to kill me. No, the usual. Writing custom computer for your program, yeah, exactly. How long have you been in software development? I don't really know what it means to be in software development, but I've been programming actively for 16, 17 years. Right. You probably mean in the industry? I don't know. Because I've been programming before I was programming professionally. So, yeah. Do we include that as being in software development? I don't know. The phrase being in software development sounds very careeristic, you know what I mean? So it's like, yeah, I'm building a career of software developer. Yeah, I have my CV and I'm adding more and more entries there. Yeah, I'm in software development for 10 years. Yeah, I couldn't care less about career, really. I don't give a shit. I like to write code, right? And I'm writing code for 17 years, regardless of industries and bullshit like that. So okay, does anyone have any other questions? What kind of software do you enjoy writing the most? I don't know. I like to make computers do things. How do you earn money with a mindset like that? Here's the interesting thing. I'm simplifying my life to the point that I don't really need that much money to actually sustain myself. In fact, I'm streaming and developing everything on a laptop that I bought 10 years ago. I think it's already more than 10 years ago. It's a very old laptop, so it barely can hold together. Have you ever tried any Swift? It has a pretty cool syntax. I couldn't care less about syntax, I'm sorry. How would you approach going in the opposite direction, Java source code to a class binary? The same way as the developers of the Java compiler do. Would write a compiler that parses the source code, produces AST, then traverses AST, maybe translates it to intermediate representation if needed, maybe slightly optimize the intermediate representation, and generate the actual code. It doesn't look that difficult anymore. I've done that several times on my streams, actually, with other languages. Okay, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you on the next stream. So yeah, love you. Mwah. Alright, looks like we're live. Hello everyone and welcome to yet another losing session. How about that? I bet you expect that shit to happen. Let's make a little bit of an announcement and officially start the stream. So let's do a red circle, right? Red circle live on Twitch. And what are we doing today on Twitch? So today we are developing a Java virtual machine in Python. Oh, let me give the link to where we're doing all that, and also ping everyone who's interested in being pinged. And there we go, the stream has been officially started. So today's stream is going to be a logical continuation of the previous stream where we developed the parser for the JVM bytecode files, the so-called class files. You can find the source code in here. I'm gonna copy paste it in the chat, and of course if you're watching on YouTube, you'll be able to find this thing in the description. Right, so I don't really want to spend too much time on this project. I just wanted to, you know, have some fun, develop something relatively simple and interesting. And on the previous stream, we managed to actually write a simple parser that can parse the compiled hello world in Java. Right, so it can parse it, it can show all the like sections and stuff like that, all of the constants and everything. So let's actually take a look at that. I think it's gonna be rather interesting. Right, so I'm gonna go to Python. I don't know why I called it like that, but it's called Python. So here is the script. It's actually relatively small. It's only 153 lines of Python code, and it can already do a lot. Not a lot, but I mean enough. So here is the compiled file, right? So here is the source code. It has like a couple of things in here just to test stuff out, but ultimately it's a hello world in Java. You can compile that hello world. I think I still don't have a compiler in my path file, right? But in that case, I just have a class file already compiled for me. So here it is. So and if you run the script, what it does, it actually parses the JVM file and shows you all of the constants in here. Also, it shows you all of the methods, what kind of classes they belong to, the actual bytecode of that file, and sort of actually execute it in the sense that find a simple, like, write an interpreter for the instructions that are already in that file and interpret only them, right? So I want to try to implement a very limited JVM that can only interpret like hello world or something simple as hello world, because then you sort of have the base to extrapolate it and maybe implement full virtual machine eventually, like for educational purposes. You know what I mean, right? So yeah, that's basically the idea for the day. So let's go ahead and do that. So let me take a look. So for some reason it tried to save the compilation file, so I'm gonna actually kill it in here. So first of all, the first thing I want to do, I want to set up the environment for my, so I can have the Java compiler just in case. So I'm going to do source opt Java environment, and there we go. I should have the Java compile in my path. There you go. It takes some time to actually load up, but it is what it is. So what else do we have in here? So I have to go, what is it called? Pajison. I keep forgetting the name of the project. Right, so I want to recompile this entire thing, and there you go. Let me see. So if we print the class, right, if we straight up print the class, here are all of the methods, right, of that specific class. So what I want to do, I want to find the main method, right? So I'm going to try to interpret the main method. So I already have a function implemented in here. Find methods by name. So here I can supply the class, and then I can provide the name main. So because of the function overloading, this thing can return